Hello everybody, so today I'm going to be talking about the product rule in calculus, and this is actually a fairly straightforward calculus lesson if you actually choose to believe it. So the product rule is used to find the derivative of the product of functions. So for example, you might see something like an expression x times y and be asked to find the derivative of that expression, and you would have to use the product rule for that. Now, just before we get started, I would like to say that the product rule and the chain rule are very simple but very fundamental concepts to finding derivatives in calculus. And if you know calculus, then you know that calculus is basically derivatives and integrals. So you really have to know the product rule and the chain rule. But today we're just going to be talking about the product rule. So the formula for the product rule is right here, and it is as follows. If you have some function f of x multiplied by some function g of x, and this is just a generic expression, then the derivative of those two functions multiplied together is the same thing as the derivative of f of x times g of x plus f of x times g prime of x. And remember that whenever I say f prime of x or g prime of x, it's the same thing as the derivative of f of x or g of x, respectively. So here are some examples, but I'm just going to reiterate and rewrite the product rules formula. And just note that since this is addition, you can really move this around as you feel. So you'll see that I didn't write this down exactly the same. You know, I can switch the g of x and the f of x, or I can even do f of x times g prime of x first, plus f prime of x times g of x. But just know I'm going to be following this formula more closely. But since it's addition, you can really switch it around, so you don't have to be super rigorous about trying to memorize the formula. So first, we have this expression, this function f of x, and we want to find its derivative. So the derivative of x, I guess I'll use a different color. The derivative of f of x is going to be the same thing. Well, first, we want to break this up into its expressions, right? And this one's pretty obvious because we have two different variables. So we have to treat those variables differently because it's an x versus a y. So first we're going to be finding the derivative of x, and we're going to treat that as our sort of f of x function, and then the y is going to be our g of x. In this case, first we're going to find the derivative of x, which is just 1, and then we're going to multiply that by y. And then we're going to add that to the derivative of y, which is also 1, times x. And so what we end up getting is that f of x, or f prime of x, my bad, is equal to y plus x. And that's it. That's the product rule. It's actually very straightforward, like I said, but it is extremely fundamental. So here's another example, and this one's a bit more complicated, but not difficult. So first we're going to find the derivative of 5 times x to the power of 3, and then we're going to multiply that by 2 times x to the power of 5. So the derivative of 5 times x to the power of 3 is the same thing as 5 times 3 times x to the power of 3 minus 1. And then we're going to multiply that by 2x to the power of 5. Next we add that to, you could do 5x to the power of 3, and then the derivative of 2x to the power of 5, which is the same thing as 2 times 5x to the power of 5 minus 1. And so if we want to simplify this, we'll get 15x to the power of 2 times 2x to the power of 5 plus 5x to the power of 3 times 10x to the power of 4 So we simplify this even further and we get 30x to the power of 7 plus 50x to the power of 7. Now for our last, or our almost last example, we're going to be doing something that's a little bit more difficult because we actually have to simplify this square root of y cubed before we actually try to find the derivative. So recall that just the square root of y, well, the square root symbol is the same thing as something to the power of 1/2. So we have the square root of y, which is the same thing as y to the power of 1/2. Now in this case, since we have, since we have the square root of y cubed, we're just going to multiply that by 3. So, or we're going to raise it to the power of 3, which is the same thing as y to the power of 3 over 2. So this is equal to the square root of y cubed. So now we can actually find the derivative using the product rule. So we take the derivative of y to the power of 3 over 2 first, which is the same thing as 3 over 2 times y to the power of 3 over 2 minus 1. And then we multiply that by 5 times y squared. And then we add that to y to the power of 3 over 2 times the derivative of 5y squared, which is the same thing as 5 times 2 times y to the power of 2 minus 1. And if we simplify this, we get 3 over 2y to the power of 1/2 times 5y squared plus y to the power of 3 over 2 times 10y. And if we want to simplify this even further, then we could say that this is the same thing as 15 over 2 y 5 over 2, because you add the 1/2 and the 2 together, and by doing that, it's essentially the same thing as 1/2 plus 4 over 2, so you get 5 over 2, plus, same thing with this, essentially there's a 1 here, so it's 3 over 2 plus 2 over 2, so it's also 5 over 2, plus 10 times y to the power of 5 over 2. Now I have one more example, and this example is really just proof that the product rule actually works. So we know that the derivative of 6y is just, well, it's just 6. We know this without having to use the product rule. But just to prove that you can use the product rule, because still this is some expression, you could break this up if you wanted into some expression 6 multiplied by another expression y. And so you could still treat 6 as our f of x and y as our g of x, and theoretically you should be able to use the product rule, and you can. So you can say that the derivative of 6 is 0, and multiply that by y, add that to our to 6 multiplied by the derivative of y, which is just 1. Well, that simplifies to 0 plus 6, because anything multiplied by 0 is 0. So you just end up with 6. And since these are the same thing, that proves that you can still use the product rule for any sort of expressions, two expressions multiplied by each other, or some sort of product.